Hello, and welcome to CS115, Intro to Computers. I am Carrie Locke, and this is Chapter 3, Computers and Mobile Devices, Evaluating the Possibilities. So this is an overview of what we'll be covering. So we're going to start with some housekeeping, and then we'll look at computers and mobile devices, desktops and mobile computers, servers, supercomputers, terminals, cloud computing, mobile devices, game devices, embedded computers, ports and connectors, wireless connections, protecting hardware, some of the health concerns with using these devices. Then we'll go over a chapter summary, and then we'll review the assignments and projects due for this. So, housekeeping. I will put up the content at the beginning of each week. Any testing will be on Fridays. Remember, this Friday we have the syllabus quiz that we didn't have last Friday. Assignments and projects will be due at the end of the week. Your assignments for this week will be due on Saturday. Changes will be announced through Web Campus. And let's review the assignments. So the grades should be up on Web Campus for the discussion and Discord assignments. The Discord took me a little bit longer because I had to verify everybody's actual account. But those should be up. If they're not up today, then they should be up tomorrow. So the HTML web page assignment, everybody did really well with that. There was an error. If you copied and pasted the code straight from the Web Campus, then it was possible there was an encoding error. I reported that through Web Campus. So I'd like to take a moment now. I couldn't do this beforehand, but I would like to take a moment now to show you some of the things that I briefly mentioned. There are some websites available online, and they're free, and that you can put up a website really quickly. This might be handy if you want to put up your CSV or your resume or some interesting information about yourself online that's readily accessible for future employers, for your educational experiences, anything that you want to put up. You can put up on one of these websites. So let me go ahead and exit out of the slides, and then I'm going to show you those real quick. So this one's Weebly. And see here it says websites, pricing, more. You can create your website. They offer templates. These ones that I'm mentioning, they offer free templates. And then, of course, they have the links to create your domain name. So this is another one. This is Jimbo. I'll mix up the cookies. So this is Jimbo. You can start your free website. I'm sure they want to sell you additional items, but you don't have to do that. So here's an example for somebody who's selling chairs. You can sell online. Can help you design a logo. And then here's Wix. Wix is one of the most notorious ones. Wix, again, all of these have templates. So basically, they have these templates for you, and all you have to do is fill in the portions that you want and delete the portions that you don't want. But they're pre-made websites, and they're really nice if you want to get something up quickly to have your presence on the web. Getting started with a classic design. So just something that I wanted you to be aware of. In addition to that, the university does offer you web space, and that would be available through OIT if you were interested in something like that. The engineering college does too. Well, there's VirtualBox. There's a peek into our immediate future. Engineering, if you're an engineering student, you have a free web space through engineering also. Computer science does also. So, on to Chapter 3. Chapter 3, Computers and Devices. Chapter 3 is an expansion of Chapter 1. If you remember Chapter 1, we went through a review of everything that we're going to be going through in the book. And Chapter 3 expands on a lot of the terms that you saw in the book, in Chapter 1. And then down here at the bottom, if you were interested in how I am preparing this, I'm using Google Slides. The slide templates I'm getting from Slides Carnival. OBS is what I'm using to do my media presentation. OBS is Open Broadcaster. It's a very common multimedia presentation software for streaming. Gamers like it. They use it quite a bit. I'm using Zoom to create this really cool, spooky effect that I'm doing here, which does an automatic green screen. And then Doodly, which hopefully I'll be using Doodly in the future, so that you don't just have to see this PowerPoint, and you'll have something much more entertaining to watch. Computers and mobile devices. So if you'll recall from Chapter 1, a computer is an electronic device operating under a set of instructions stored in its memory that can accept data as input, process that data based upon a specific set of rules, produce information, which is the output, and store the information for future use. So a mobile device is just a computing device small enough to hold in your hand. Those include terminals, smartphones, digital cameras, ebook readers, portable media players, game devices, embedded computers, etc., etc. If you can think of it, and it has the definition of a computer in it, and it can fit in your hand, then it would qualify as a mobile device. Personal computers, as opposed to other type of computing devices, are a computer performs all of its input, processing, output, and storage capacities by itself independently and is intended for use by one person at a time. So your book has a definition here, and it says that personal computers are usually differentiated by their OS. I'm going to go ahead and read this. Dell, Lenovo, and HP, they give examples. Generally use the Windows OS. Mac usually uses the Mac OS. Mac OS is actually a Linux, customized Linux BSD operating system. So personal computers, Dell, Lenovo, HP, personal computers do not need to be Windows OS. They can support Windows operating system or the Linux operating system. I'm not sure why the book stated that. Maybe they know something that I don't. So, yeah, Dell, Lenovo, HP, desktops, laptops, you can install Linux, the Linux operating system, on any one of those. Desktops and mobile computers. So a desktop is a stationary personal computer. It generally has a monitor, keyboard, and mouse that are separate from the tower containing the processing components, with the exception of all-in-ones, in which the monitor contains the processing components. So a laptop or a notebook is a thin, lightweight mobile computer with a screen in its lid and a keyboard in its base. It operates on battery or power supply or both, and they generally weigh up to 10 pounds. Ultra-thin laptops weigh up to 3 pounds. One thing they didn't mention here is there is a special class of laptops called ruggedized laptops. Those are generally used for field work, and they are encased in rubberized cases, and they have special components that are designed to absorb shock a little bit better. So you'll find those in special purpose uses, such as construction workers, field work research, those sort of things. They tend to be about 3 times as expensive as a regular laptop, and at least 3 times as sturdy as a regular laptop. So a tablet is a smaller laptop or notebook, generally without a keyboard, usually has a touch screen. It's somewhere in size between a phone and a laptop. Now, as we go down this list, remember, not always, but generally speaking, we're reducing in processing power. So laptops are generally not as powerful as desktops, and tablets are not as powerful as laptops. Servers, fun stuff, fun stuff. So a server is defined as a computer dedicated to providing one or more services to other computers or devices on a network. I would expand that to say it can also provide services to users. It can store content, control access to hardware or software or other resources. It may be on a server accessing another server. So, and it may be users or devices accessing the server. It can support 2 to thousands of computers, devices, or users at the same time, and they range in size from small, high-end desktops, which can be used as servers, or large room size. So servers you'll generally find for corporate uses, government uses, internet application. They tend to be expensive and used to support daily operations. Types of servers. There's lots of types of servers. There's an application server, backup server, database server, DNS. Remember we learned that one, domain name service server, file servers, FTP servers, file transfer protocol servers, SMTP, it's a mail server, print servers, web servers, game servers, and then some people have home network servers. So an expansion on servers. The physical types of servers include rack-mounted servers, which are servers mounted inside of a rack. Blade servers, they have blades that you can swap out while the server is still running to swap out different resources, either expand or reduce, usually expand resources to increase the power and capacity of the server. And tower servers. So these are servers built similar to desktop structure. So in this section, they also covered server virtualization. So server virtualization is software used to emulate physical servers. The purpose of this is to divide physical servers into logical servers. This way you can share the resources. This is the birth of cloud computing. So a server farm is a network of several servers in a single location, and a mainframe is a large, expensive, powerful server. It can handle hundreds of calculations or thousands of connected users simultaneously. High-level research, mainframes tend to be, they tend to handle more throughput. I gave you a link on this to explain mainframes a little bit further. I gave you links on servers, which are really fun. Some of them are really quick, and they'll really help you out as far as servers, and really give you an inside look at some areas that you wouldn't ordinarily get to look at. Here I want to pause and I want to show you exit, I want to show you Oracle. So we talked about virtualization briefly. I'm sorry, Oracle's VirtualBox. So VirtualBox is virtualization software. You can use virtualization software on your desktop. So if you have a Windows PC, Windows operating system on your PC, and you would like to install Linux, say you said, I just want to, I don't know what this Linux thing is, and I want to give it a try. You can, Linux is the free version of Unix, by the way. So Linux VirtualBox offers you a mechanism to do that. What it does is it is a virtualization it is virtualization software that allows you to virtualize operating systems, and it's available for free. And you can install this, and then inside of this you install the Linux operating system. So I have a couple of pictures here that might help explain that. So this is Windows inside of a Mac. Now I say inside because it is sharing the resources of the Mac operating system. So the Mac is what they call the host, and then the Windows is inside of that. So it's a client inside of that. So as you can see, you have Windows 10 inside of a Mac, running inside of a Mac, which is pretty cool. And now here you have Windows. So that's actually Windows 7. So you have Windows 7, but you have VirtualBox running, and inside of VirtualBox you have the Ubuntu operating system, which is a very popular Linux operating system right now. Okay. Supercomputers and terminals. So, supercomputers, they're servers, and they're fast, expensive, powerful computers. They process trillions of instructions per second, and I'm sure since this book was written that number has gone up by a lot. That number is way low. 100 plus tons, 20,000 times the data and information of a desktop. They're used primarily for research, medicine, aerospace, automotive design, online banking, weather forecasting, nuclear energy, petroleum, exploration. So let's move on to, before I move on, I gave you some links for supercomputers, which are pretty neat. We have a supercomputer at UNLV, and you might not know this, but we have a supercomputer. We've had a supercomputer at UNLV for years. A lot of people take classes and attend and maybe even work and teach at UNLV and might not know we have a supercomputer. If you remember the internet lecture, there were 4 schools that connected together. So they connected together to become what is today the internet. And since then, schools have become, universities specifically, have become very, very instrumental in computer advancement, research advancement, all of the things connected to computers. It's a very basic way of saying that, but everything computers, universities are very instrumental, and UNLV is one of those. Just thought you might want to know that. Terminal. So a terminal is pretty much the opposite of a supercomputer. So it's used to send and receive information to and from a host or a server. It is very limited in processing power. The server is the one that does all the work. So it could have a monitor, a touch screen, a keyboard, memory. But even if it has those items, I mean, the monitor and the touchscreen, the keyboard, the memory, the hard drive space, if it has those items, it's very limited in those items. RAM, hard drive space. Its point is not to process anything. It's only to process enough to get the data to the server and then to present the data to the end user. So terminal examples would be point of sale, which are your registers, an ATM, kiosks. Those are all good examples of point of sale. Cloud computing, the mystery of cloud computing. When it rains, do I lose all of my data? When it rains, does my data come down in the rain droplets? Cloud computing. So this term is a marketing term. So cloud computing has existed as long as servers have existed, as long as terminals have existed. It's just a bunch of servers. There have been leaps and bounds in advancements that have customized the cloud experience. Don't get me wrong. The cloud is a very specific market, and the servers are interconnected. So let me explain what the cloud is. It's an environment of servers that house and provide access to resources users access through the internet. It is a marketing term. It's commonly used for email messages, schedules, music, photos, video games, websites, programs, web apps, servers, storage, server storage, I think would be better for that, and more. Instead of accessing the resources locally, which would be, say, at your PC or on your phone, you access them on the internet / the cloud. So the idea of cloud computing is, and as I said, okay, the idea of cloud computing is you are not storing the data locally. You're sending it off to the cloud. You're not accessing it locally. You're accessing it via the cloud. The same thing that we just said about servers applies to cloud computing. Where the cloud, the name the cloud has advancements is that it tends to be redundant. In other words, it tends to be a network of servers in separate locations, generally speaking. So Google's cloud or Google Drive, Google doesn't share all of your, doesn't store all of your data on a single server. Google has servers spread out across the country, so your data is saved on multiple locations. Amazon is the leader in this area. AWS, which I'm going to show you in just a moment. Amazon Web Services at AWS. They are by far the market leader in this area. But businesses use the cloud for backup. And we're going to get to hardware issues later, and you'll see why the cloud might be a good solution for businesses. Users, chat logs, Twitter, corporations, wikis. The cloud is the original image of the internet, which is, if you remember, that's kind of curious. The internet is generally drawn as an actual cloud. So putting those two thoughts together, if you're saving your data out to a server on the internet, then that is the cloud. So some genius, and I don't know who came up with the term, but some genius married those two concepts and came up with this great marketing term, which works. It works really well. I pay Apple to save my iPhone data off to the cloud. So I pay them every month to save my data. So it works. The cloud image works. Cloud. Before you save anything to the cloud, just as an FYI, from a computer standpoint, from a computer science standpoint, you're always supposed to encrypt it. If you encrypt your files prior to saving them to the cloud, then if something happens on the cloud from a security standpoint, say Google had a security breach, a hacker hacked all the different locations, or hacked Google Drive, and it affected all the different locations. If your files were encrypted prior to storing them on Google Drive, then that would be okay with you, because they would have to decrypt your files in order to have access to them. So before saving anything to the cloud, you should always encrypt them. This is security bullet point there. Let me go ahead and show you AWS. I was going to make this an assignment, so at least I'm just showing you the website. Okay, AWS, there is a free tier of AWS, and you can create a free account on AWS, and you can poke around and see all the different stuff that they do. It is always free, as they stated here. Where AWS makes all of their money is by the number of connections. So say you build a website and you put it up on AWS, they make their money on the number of people that connect to your website. So once you exceed a certain number of connections, then they start charging you. Or the same thing with data. You're allowed to store as much data as you want. I'm sorry, I can't say that for sure, but you're allowed to store data up to a certain amount. There you go. So 5 gigs. Be careful with this, because you may be able to store it up there, but retrieving it may be another story. So while you may be able to store, double check and see if there's a charge for retrieving that data. I have heard rumor. And then here you see the number of hours, okay, number of gigabytes. They have Lambda, which is one of their own coding languages. So, and then they have all these different products. They also have developer tools. They have their database. They have game technology. They have all sorts of stuff. It's a good option for businesses, especially businesses just starting out. Back to the slides. Mobile and game devices. Let's check the next slide. Okay. We're going to get through this slide, and then I am going to break the video. So mobile and game devices. Mobile device is a computing device that's small enough to hold in your hand. Small screen, usually 3 to 5 inches. Smartphones, digital cameras, portable media players, ebook readers, GPS devices. They are generally wireless, touchscreen, or a keypad. Smartphones qualify as a wireless device. A smartphone is an internet-capable phone that is also a PDA camera, has text capabilities, has video calling, games, and nowadays an unlimited amount of apps that you can install to make your camera do pretty much anything you want it to do. It can be a ruler, it can be a compass, anything you want your phone to do, there's an app to do it. Digital camera allows you to take and store digital images. Portable, just a quick note on digital cameras. Kodak, which is from my hometown, almost disappeared because of digital cameras, because they thought for sure that nobody would ever want a digital camera over an actual film camera. They underestimated that one. Portable media players, store, play, view digital media. Portable media players nowadays are on your phone. Well, most people have that capacity on their phone. Ebook reader, electronic book reader, GPS system, portable map, console device, provides real-time map, location, and direction via satellite connection. Game consoles, computing device designed for single or multiplayer video games, usually connects to a TV, has internet capabilities. You can listen to music, watch movies, view photos, and nowadays, again, you can install applications on them. So a lot of your video game consoles are becoming your television central. So anything you need for your television, your Netflix, your Hulu, anything you need, your DVD player, Blu-ray player, anything you need is right there on your game console. Handheld game consoles are just portable, fit in your hand. And I am going to break the video here.